What we're going to do now is we're going to calculate the shortest route between 2 points. So, as discussed earlier, when we have a line segment, the shortest distance occurs along the perpendicular line that crosses the 2 points. Now, basically, Mrs. Gerber has been captured, and she's in the middle of a frozen lake. She's desperate to get home to see her dogs. She opens her door and hears the sound of traffic on a nearby road. The coordinates are 6, 1.5, and the nearby highway has coordinates A25 and B10, 4.5. What's the shortest distance to the highway? So in this case, we have something that kind of looks like this. And just like before, as I said, if I have some line segment AB, right, and I want to find the distance from this point where my smiley face is to the line, I have to use the perpendicular of this slope and then come up with the equation, then use those two equations to find the solution. Now, I'm just going to go and do a rough solution so you have an idea how to do this. The answer should be perfect. Now, how are we going to do this? Well, the first thing that you're going to do is you're going to calculate the slope of AB, and then you're going to tell me what the perpendicular of AB slope is. Then what you're going to do is you're going to find the equation of AB and the equation of the perpendicular line. So you're going to find the equation of this line, and then you're going to find the equation of this line. Then what you're going to do is you're going to find the intersection, and we're going to call it H, by solving the system. Now, the system of those two lines that we created in section 2 here. And then finally, once we have that H value and our G value, all we have to do is find the distance using the distance calculation. So now let's go and do that. So here's the solution for today's problem. The first thing that we have to do is we have to go and calculate the slopes. So for one, we calculate the slope of MAB and we get this. Okay, and our final answer ends up being the slope of AB is -1/2, which means that my perpendicular slope for AB is going to be 2. Remember, the perpendicular of any slope is the negative reciprocal. So now, we have to go and calculate the equations of those lines. So let's start by identifying this section as the lines that we're looking for. So let's go and find the slope and equation for MAB, for the slope of AB. So we start with our basic equation from y equals mx plus b, and then we solve for b by taking one of the points. We're taking either 10, 4.5 or A 2, 8.5, and subbing in for x and y. And when we go through this solution, you notice that 4.5 can be written as 9/2. So now you've got two fractions which are on either side, and all we're going to do is bring those to the other side to get something like this, which simplifies to 19/2. Now, notice I'm leaving that as a fraction. I'm leaving that as a fraction for you guys as a challenge for later. Now, in order to calculate the equation of the line for the perpendicular, we're going to start with this equation. Y is equal to 2x plus b. And we're going to use 6, 1.5 from our equation. Now, 6, 1.5 was our g value. So we substitute in, and we get something that looks like this. Okay, now, what we have to do at the end is we have to state the equations for both of them. And now, I'm going to take the time to make sure that I make these final equations look like a system. So, for the lines are whatever, but we're going to use that to eventually solve for H. So I'm going to put those in a system type format so that we can do so. So we start with the first equation. So we had b is 19/2, so we should have y is equal to negative 1 half x plus 19.2, 19 over 2. And then for the second equation, we're going to get y is equal to 2x minus 10.5. I'm going to label the first equation 1 and the second equation 2. And because we have two y's here, which are equal, what we're going to do is we can either equate the two right sides together and solve for x, or we can simply subtract the two equations using elimination. Now, if I do that, I'm not sure. I might not feel comfortable with with these fractions and decimals. So maybe I want to turn everything into decimals and then everything into fractions, then calculate. So what I'm going to do is I'm going to change my equations to look something like this. Both of my equations are going to have fractions for any decimals that are there. So in this case, the first equation doesn't change, but the second equation does. So I'm going to change 2 in front of the 2x to be 4 over 2x. And then minus 10.5 is really just negative 21 over 2. So when we subtract those two, we're going to get this equation. 0 is equal to negative 5 over 2x plus 40 over 2. Now, we're going to take the 40 over 2 and move it to the other side. So now we get 5x is equal to 40 over 2 in the end. And now, in order to get rid of the 2's on both sides, we multiply both sides by 2. And there's some cancellations, and we end up with something like this. 5x is equal to 40. And we end up with x is equal to 40 divided by 5, which means x is equal to 8. So now, because we found x equal to 8 for these two equations, what we're going to have to do is we're going to have to back substitute into equation number 1 here. So we're going to take x equals 8 and plug that back in. So we sub x equals 8 into equation 1 and we get something like this. And when we solve, we end up with y is equal to 11 over 2. So now, you just have to realize, so the intersection is 8, 11 over 2, and we're going to let that be our h value that we had described in our original picture here. So now, let's continue. So for the final step, what we're going to do is we're going to change h into a decimal, because I'm sick of using decimals here. Sorry, fractions. So 11 over 2 is just 5.5, so h is 8, 5.5, and g is 6, 1.5. So now we're going to calculate the distance of h, and we get the following. Now you'll notice you get the square root of 20, and then we can take the square root of 20 and break it into the square root of 5 times the square root of 4. And we put the nice, easy square root in the front. We simplify and we get 2 root 5, or 4.5. Okay? Now, you could have stopped at the square root of 20 and given me 4.5 as my final answer, and that would have been fine. But if I ever asked you for the exact distance, you would have given me 2 root 5. Your homework is on your worksheet. Good luck.